Okay, guys, section 9.7, the tangent ratio. There are really two things that we need to talk about today. And first off, I just want to read this part right here. Well, that's not what I want. Okay, a trigonometric ratio. A trigonometric ratio. Tri means three, right? We're measuring angles, three angles, so we're using measurements from triangles. That's what trigonometry means. And it's a ratio of the lengths of two sides of a right triangle. Okay? Now, a basic trig ratio, one of the basic trig ratios, we'll go over the other two tomorrow, is the tangent. Okay? And the tangent always equals the length of the opposite side of the angle over its adjacent side. Okay? Now these are only sides, they're not hypotenuse. Tomorrow we'll talk about sine and cosine, and that deals with the hypotenuse. But the tangent is the length of the opposite side over the adjacent side. So let me show you what I'm talking about. Let's say that I have this angle, or this triangle, and I'm going to say that this is A, this is B, and this is C. I'm going to say that the length of this side is 5, this side is 12, and this side is 13. Okay? So there's my triangle. Now, I might ask you, or someone might ask you, what is the tangent of angle B? Okay? Here, let me write that a little bit better. The tangent of angle B. Okay? Now, the tangent of angle B equals the side opposite B, which is 5, over the side that's adjacent to B. Not the hypotenuse. 13 is the hypotenuse, but we're not including that here. We're using one of the sides that make up angle B. So the tangent of B is 5 over 12. It's just a ratio, and a ratio is a fraction. Okay? Now, I might also ask you, what's the tangent of A? The tangent of A is going to be a ratio, so a fraction, and it equals the side that's opposite A, and I'll do it in a different color. The side opposite A is 12, and the side adjacent to A is 5. Not the hypotenuse again. Remember, the hypotenuse is involved in sine and cosine, and we're going to talk about that in the next lesson. So the side adjacent to A is 5. So that's how you find the tangent ratio. That's it. Okay? This stuff actually equals, this number is going to be 2.4, and 5 divided by 12, I don't know what that decimal is, but let's see, get my trusty calculator. This is approximately 0.4167, okay? And that stands for an angle, and we'll talk about that later. The tangent of angle B is equal to 0.4167. All right? Now there's one other thing that we want to do. Each angle has its own tangent ratio. So you can see here that the tangent of 32 degrees equals 0.4245. Okay? Now, using my trusty calculator, my scientific calculator, which you guys have available on your laptops, right? Let's just find the tangent of 12 degrees. All I do is I type in tangent, I hit the tangent button, I type in 12, and I hit enter. And on my calculator, I got 0.212556562. But it's traditional that we keep it to just 4 places. Trig ratios are normally 4 places. Okay? So the tangent of 12 is approximately 0.212526, because this number is 5 or greater. Okay? So that's the tangent of 12 degrees. Now, something that you need to do, just before I let you guys go on this introduction, one thing you have to do is make sure that your calculator is in the degree mode, because another way of measuring angles is the radian mode. So you always press the mode button and make sure that degrees is the one that's highlighted, the DEG, not the RAD. Okay? All right. Good job, guys. I think we're ready to look at that first example. See you there.